Good evening, sir.
All right, good evening. Who was that, Dorcas first?
No, Latavia.
Oh, Latavia.
Yeah.
Okay, yes, there you are. Yeah, so many people came in at once, it's hard for me to find.
Oh,
Anyway.
yeah.
Hey, Mr. Ray.
All right,
I'm here.
good. Okay, hi, Dorcas. I see yours lit up
Hi.
just now. And I thought I heard someone else speak.
Oh, Jacob.
Oh, Jacob. Yes, good evening, Jacob.
Good evening.
All right, so welcome everyone. I'm just gonna, as usual, I will be writing down your names as they. All right, so welcome, George.
Yeah, Mr. Ray, good evening to everyone.
Yes, and hopefully you're having a good evening so far.
Yeah, it's good.
That's good, that's good. All right, and Veronica, welcome, Veronica.
Hi.
And my pen ran out right while I was writing. Let's see.
Marisol Sanchez.
Be serious. All right, so sorry about that. Jacob, welcome again.
Thank you.
You're welcome. My pans are in and out, like they have ink in them. I'm not sure what's happening. Maybe it's the book. All right, and good day, Norma. Good evening, Norma.
Hi, good evening.
How are you doing today?
I'm doing good. How about yourself?
Doing well, thank you. Just trying to get this pants, all my pants to work. What is happening?
That's okay.
Yeah, seems like they all die at the same time. All right, here we go. All right, Maritza. Good evening, Maritza.
Good evening, Mr. Ray.
How are you doing today?
Fine, and yourself?
I am doing well, thank you. And Latavia, welcome again. Just writing down your name this time.
Yes, sir. I'm here. Good evening.
All right, and hope you had a great day as well.
I did. Thank you. Hope you had a good day.
Yeah, so far so good. Daniel C, welcome.
Hey, Mr. Ray, how you doing?
I'm doing well. Good to have you
Good.
again.
Hey, Mr. Ray, I wanted to let you know, I signed on today just to let you know that I wanted to thank you and the rest of the class, but today would be my last day, being that I passed my test. So,
All right, it's like bittersweet.
yeah,
That's what's up.
bittersweet.
Congratulations.
Language arts. So
You said you didn't have.
that'll be my last course.
All right, just language arts left.
Yes, just language arts left. You know, I made a goal to try and do all this in 3 months, and I'm on schedule. So
That's good. That's great. If you don't mind, send me the score privately. I would like to know what you got.
Yeah, it was a lot lower than I expected, but you know, it's a passing grade, so.
It's passing grade, yeah. And we
That's
didn't
it.
really get to algebra yet either. So, you know, the
Right.
fact that you passed it without the algebra part, that's really good.
Right, yeah, no, I had a lot of help on that part with my daughter. She's a CPA, so she helped me out a lot, so I was able to
Okay,
advance.
perfect. Right.
I was able to advance some there, but anyways, thank all you guys, all the, you know, fellow classmates. I appreciate you guys' participation in this as well, and we'll see you on the next class.
All right. Thank
Okay,
you again,
thanks.
Daniel, and good luck in all your endeavors.
All right, likewise, take care.
Thank
Good
you.
job, Daniel. Congratulations.
Thank you, Jacob.
Congratulations.
Thank you, Dorothy.
Congratulations.
Thank you.
Well done, well done.
Thank you, George. We'll
Yeah.
talk to you guys later. See you.
We'll definitely miss you,
welcome.
Daniel.
All righty, thanks.
All
Bye-bye.
right. Have a great evening.
You too.
All right. Well, you see that Daniel pass, and the rest of you, hopefully you'll be following really soon. And we have you guys up and ready. If this is your last one, you'll be done, certified. And if not, you'll be moving on to your next course to pass. So keep the end in view. All right, so I was at Adriana, so welcome, Adriana. All right, William, good evening, William.
Hey, how you doing, Mr. Ray?
I'm doing all right. How are you doing?
Good, thank you.
That's great, that's good. And hopefully you had a great day as well.
Yes, I did, thank you.
That's good, great. All right, Daniel, N. Welcome, Daniel. All right, Dorcas, welcome again, Dorcas.
Yes, thank you, Mr. Ray.
You're welcome, and hope you had a great day as well.
Yes, I'm trying.
Okay, one step at a time. Salvador,
Yes, sir. Good
welcome
evening,
again,
sir.
good evening. Hopefully you had a great day today.
Yes, sir.
All right, and let's.
I'll be your student for a long time, Mr. Ray.
Oh, no. Hopefully you'll be, I like having you guys here, but hopefully you'll be done soon. All right, Marisol, welcome.
Hi, Mr. Ray. Thank you.
You're welcome. And Sergio, welcome again.
Hi, how you doing, Mr. Ray?
I'm doing well. And Alma, welcome. I just realized the time, so I'm trying to go a little bit faster now.
Hello, Mr. Ray.
Good day, how you doing? And Justine, welcome again. And I think that's everyone.
Thank you.
All right, perfect. That's everyone that's here so far. All right, so we're moving on. And any questions on any of those worksheets that I sent? Susanna, I got you. I might have said your name right when Daniel, right after Daniel, so you might not have heard that. All right, any questions? Any questions from the homework? The worksheets?
No, sir, I'm good.
Okay. Anyone else? All right, sounds like you guys are all good to go. So let's see where you are. We're gonna go ahead and try. We're gonna go straight into it. At the end of the other class, I saw that some of you were having a little bit of issues with the metric conversion. And I'm gonna share my screen and gonna allow you to try a problem. Since everybody is doing okay, we should be able to get through this relatively quickly. Just bear with me, I'm trying to write down Dina's name as well. Welcome, Dina. All right, so this is from the workbook. All right, so let's try this one here. It says for one print. So go ahead, try that out, see what answer you get. Says for one print, number 5, for one print, an artist uses 50 milligrams of blue pigment, 55 centigrams of green pigment, and 3 grams of red pigment. How much greater is the mass of red pigment than the combined mass of the blue and green pigments? All right, so that's what you want to start off on. So once again, it's number 5 there that we're doing.
I sent my answer, Mr. A.
Okay, let me go check that. Did you? Okay, got it now. All right, well done. That is correct. So Jacob, while you're waiting, you might as well try number 9 there. Or even number 8, but we're just gonna
Okay.
practice it out just a bit more.
Are we doing both?
Yeah, we're gonna do a few. I just wanna really make sure everybody understands how to do the metric conversion, because that will pop up pretty often since it comes up in geometry as well.
Okay.
Mr. Ray, I'm
Yes.
sorry, but what page are we on?
Well, it's page 31, but it's the question that's right here, number 5. So we're doing this one.
On the workbook or in
This is
the,
in the workbook.
okay.
Right, Adriana, that's correct as well. William, that's correct. And I'm writing back. All right, I'm about to start it. Any troubles with number 5? Is there any challenges in doing that? All right, I had a
I
few
did.
answers. Go ahead.
I did. So can you explain that one to me, please?
Okay. For this one, it's a 2-step question. So you have to be careful of 2-step questions because they normally will have the first step of the first part of that answer in the choice selection. So for this one, sometimes it's good to get what we call a verbal model, just so that you understand what you're doing. It says how much, the last part of the question says how much greater is the mass of the red pigment, which is this one here, than the combined mass of the blue and green pigments, right? Sometimes it's good to really know what you're doing there. And so basically, I'm going to find the mass of the red pigment, and I'm going to subtract the value of the blue and the green, right? So hopefully you can see that. Sometimes getting a picture of what you're going to do can make it a little bit easier. So you're basically going to be finding, right, I'm just writing down, someone just came in. You're going to find the difference between the red pigment and the blue and green pigment. Now notice all of your answers are in grams. So although it's not stated in the question, you can tell by the answers what you want all your units to be into. So the red pigment is already set in grams. So you're not going to have 3 grams subtract something else. So you need to find out what your blue is in grams and what your green is in grams. And I have something in the chat. All right, Veronica and Dorcas, that's correct. All right, so to find the blue, to convert that, like I said, there are different ways, but I'm going to try to stick with one way so it's not overwhelming. If you do know another way and it's working for you, it's totally fine to stick with it. Like I said, I could show you multiple ways to do this. As long as you understand the decimal system, it shouldn't be hard. Now this says 50 milligrams, and if you remember what milli means 1 thousandths. So that's literally 50 thousandths, right? Or you could write it as 50 thousandths. Both of these are the same thing in grams. That's 50 thousandths. Now remember, for the 50 thousandths, you don't really need that 0. As the choice is yours if you want to have that 0 there. So now that I know what the actual decimal is, that's 0.05 plus, and now I just need to change the green. This is 55 centigrams. Do you guys remember what centi means?
100.
100. So that's 55 hundredths. Or, oops, sorry. All right, so we have 55 hundredths, and did I write that out?
No. Isn't
Sorry,
it just point 55?
Pardon? Oh yes, thank you. 55 hundredths. I said hundreds and I wrote thousands. Thank you. Sorry, is all this trying to, it's trying to be fancy, can mess you right up. I'm trying to have like the same colors and all that stuff. All right, so 55 hundredths. There we go. So remember, we have 50 thousands on the top and 55 hundredths on the bottom. So we have 0.55. All right, if we were to add those together, just think of that as like 5 cents and 55 cents. How much would I have?
0.60.
0.60, right? So that's going to be 3 grams minus 0.6. That's what those two are going to add up to. If you don't see it, remember we did addition of decimals. Just add the columns. So 5 plus 5 is 0. Carry the 1. The 1 plus the 5 gives you 6. And bring down the zeros. So that means all you need to do is say 3 subtract 6. Hopefully you can see that. That's like having $3 minus 60 cents, right? If you had $3 and you subtracted 60 cents from it, how much would that be?
240.
240, right? I'll put the 0 back there so you could make it easier. So 3 subtract the 60 cents or 60 hundredths. It's going to give us 240 or just 2.4 as you see here. And that would be the final answer. All right, be careful of C. C is a popular answer to choose because sometimes we don't read it carefully and we might just add everything up. So we have to be very careful. If English is not your first language, then you really have to try to underline the key words. And that's normally by looking at the question mark. By finding the question mark, you can find exactly what you're looking for in the question. So that answer there would be 2 4/100. Any questions with number 5? All right, so it sounds like there's no questions there. I had given Jacob the opportunity to go ahead and do number 9. You might not have had the chance if you had not finished.
I tried to, no.
No?
And I jumped to number 9 and no. So
Okay.
we can do them together.
All right, now I was just going to say that, but since you let me know that you didn't have the answer, then yeah, we're definitely all doing it together more than likely. Did anyone try number 9 before I say that? All right, so
No.
no, okay, let's look at number 9. That was the second one that I said to do if you have finished number 5. For number 9, it says objects on the moon weigh generally 1/4 as much as they weigh on Earth. If a parcel weighs 3 kilograms on the moon, oh, that's a weird question. Its weight on Earth would be what? So if a parcel weighs 3 kilograms on the moon, his weight on Earth would be what? So you have a choice. With these, I suggest using proportions because you're kind of working your way backwards. And so it's what we call the inverse. So if this was the Earth, you would say 1/4 times 3, but it's on the moon, so you're doing the opposite. So instead of 1/4 times 3, you're doing 3 divided by 1/4. So it's the inverse. But it's easier, like I said, to write it out as a proportion. And so the way that we would do that,
Mr. Ray,
yes.
the term or the way it was presented that messed me up, it says as much. So what would as much mean?
Okay, so
More
let's say,
than?
well, it's literally saying 1/4 of. So a quarter of whatever is on the Earth. So if on Earth it weighed 8 pounds, then on the moon it would weigh 2 pounds. 1/4 of 8 is 2.
Okay. Yeah, because on the moon things are seemingly lighter than what they are on Earth because of gravity, right?
Right.
Okay, so lighter.
Yeah, so because it's lighter, then the actually, well, if it's on the moon, and that's a way to think of it too. Whatever's on the moon is lighter than what's on the Earth. So if you're looking at something on the Earth, I'm sorry, the moon, how much would it be on the Earth? It's going to be greater.
Yeah.
So instead of 1/4, you're going to actually multiply it by 4. So just be the opposite. So instead of saying 1/4 of, and let me replace it with 3, this is the logical way to do it. Instead of 1/4 of 3, it's going to be 4 times 3. So opposite of a quarter is a 4 of a 1. So you're doing the opposite. All right, so that's just using logic that if I'm doing it on the moon, I'm doing the opposite thing. If you were to write it in terms of a ratio, let's see, you could say, all right, so we can say the weight on Earth to the weight on the moon is 1/4 to the thing. So we could say 3 kilograms on Earth, on the moon, and how much kilograms on Earth. And the relationship, what we want to have there is 3 to 1/4. That way it's going to be a little bit challenging to write that. Yeah, I'm gonna stick with the other way because I can see this way might cause some confusion with the fraction. Let me see. I'm trying to think of a way to make it easy to explain there.
Mr. Ray.
Yeah.
So that being said, so if let's say we multiply 3 by 4 equals 12, but we get 12, but obviously the answer 12 is not here. So we have to go with this other choices, correct?
Right, you have to go, actually 12 kg is the same as 12,000.
Okay.
So your answer is D. But I was trying to come up with a way to do it basically with the fraction, because we haven't done a problem like this. And I know we're already having some trouble with the metric conversion. So I was trying to think of a way I can make it easy to explain. But basically, yeah, it's 12 kilograms that you get, right? 4 times 3 is 12 kilograms. And you notice, like you said, kilograms is not on here. And so that means it's either going to be A, B, or D. And so you can convert to C. Now, hopefully you know that 12 kilograms is not the same as 12 milligrams. Hopefully you just know off the bat that 12K means 12,000. And so the 12,000 would become 12,000 grams. And so the answer there would be D. Now, to try to do it with the fraction in terms of proportions, we haven't got one. Say that again. Is somebody saying something to me?
No.
Okay.
Background.
All right, so does that make sense though, the way that I showed you how to do it there?
Yes.
All right, so let me try to see if I could write it up in a proportion in a way that's might be easy for those who like proportions. So basically the relationship on the moon is that everything is 1 to 4, right? That's what a fourth is. Everybody understands the fraction of fourth?
Yes.
That means whatever is on the moon, if I had 1 kilogram on the moon, how much would it be on the earth?
4.
4. So we can write it as 1 to 4, literally the fraction, where the 1 represents the moon and the 4 represents the earth, right? So whatever is on the moon, it's 4 times that much on the earth. So 1 to 4. Remember, that's literally what a fraction is, 1 to 4. So if it's 3 kilograms on the moon, how much will it be on the earth? You could also write it as a ratio. Right? This is, actually we did do one like this with the cars. We did a fraction with the car, but I did it as a ratio that time. 1 to 4, and then we have 3 to what? Right, you could do it that way as well. And you see that this one, you have to times it by 3. And over here, you could times that by 3. That's how you could get to 12 as well. If you're doing it with the proportion, then you multiply that together, you have X, and you multiply that together, you get 12. And once again, it's going to be 12 kilograms. You notice kilograms is not there, but hopefully you mastered the prefixes. And kilo means 1,000. So that means X would be 12,000 or 12 times 1,000. And so that's 3 ways that you could do it: using logic, using ratios, or using proportions. Does that help?
Yes.
Okay, good.
Yeah, thank you.
Okay. All right, we're gonna do another one. I really wanna make sure you guys are comfortable with this because you're gonna be doing a lot of problem solving in algebra and also in geometry. And this is literally the foundation of it. So I'm about to clear the screen, so if anyone's copying one or the other, just remember the one on the top here, this is the second way to do it. The first way I use logic, and the third way here is proportions. So those are 3 different ways. Just don't mix them into one problem or one answer. All right, I'm clearing in 3, 2, 1. All right, so let's try another one. I saw somebody send me number 6. Who is that? Somebody sent me an answer for number 6. So we can do number 6. Adriana, you had sent me an answer for number 6. And so I think you had already tried it. So number 6 starts up here. You could turn there on your same page, number 31, if you're in your book. Number 6 says, Sabrina is making the route for an upcoming cross-country foot race. She keeps a record of the number of meters she marks each day. Once again, here's the relationship. Look at the prefixes. 1 kilometer is the same as 1,000 because that's what kilo means, 1,000 meters, right? 100 centimeters, this one is just working backwards because 100 centimeters, right? 100 centimeters, centi means hundredth, so 100 hundredths equals to 1 or 1 meter. Right, same with 10 milliliters. If you used to write it out just by the name and prefix, milli means thousands. And so if you were to simplify this, you could simplify it down to 1 centimeter. So 10 milli means thousandths. Those zeros cancel, you're left with 100th, and 100th literally means centi. So that's 1 centimeter, right? So there's a lot of ways you can look at it, but the more you practice it, the more you start to see it. Not sure if anyone was copying that. All right, so basically, these are the measurements that we want to use to help us with number 6. So number 6 shows the cross-country race. In day 1, 700 meters. Day 2, 600 meters. Day 3, 800 meters. And day 4, 1,000 meters. And I see an answer in the chat, I think. All right, so Veronica has sent in one. All right, so the question asks is, how many kilometers of the cross-country route did Sabrina mark on day 1? And hopefully you could just look at that and tell. That's 700 meters. Notice everything is in kilometers. But if you are mastering your decimal number system, that shouldn't be too difficult. And it looks like 3 people have that answer in, or if 4 people have that. All right, 700 meters. Remember, how many meters makes up a kilometer? And that's how you can find it. And looks like most of you have it. A good bit of answers have come in as D, and that is correct. 700 meters is 0.7, right? 700 meters out of 1,000 meters, right? That's part of a whole. She ran 700 meters out of the 1,000 that you could write it as. And if you do that, 7 divided by 10 is 0.7. Or, right? Because it's 700 meters is right before 1,000. And most of you could possibly just see that, hopefully. And so the same thing here, if that's 0.7, I'm not sure what the rest asks. Let me see first. Okay, that one's a total. So let's just do that real quick. Let's write everything in terms of kilometers. So we have 0.7 there. How much would be on day 2?
0.6.
0.6. How about day 3?
0.8.
0.8 kilometers. And what about day 4?
1 kilometer.
1 kilometer.
1 kilometer, right? So that can help you too, sometimes just doing that, right? And I sent you those worksheets. If you practice those worksheets, you're gonna start to see shortcuts because it's all based off of the number 10 and hundreds and, you know, all that 1 followed by zeros. All right, so number 7 says, how many kilometers of the route had Sabrina marked by day 4? So you just need to add those up. And because it's in kilometers and really have them converted to kilometers, you can do that really quickly. So I'm gonna scroll down just a bit because I can't see the answer selection. All right, and let me see in the chat. Okay, nothing in the chat. All right, so how many kilometers of that specific route did Sabrina mark by day 4?
2.1.
A little bit higher.
3.1.
Yeah, somebody, I don't know.
3.1.
Oh, my bad, Mr. Ray. So I added the 7, 6, and 8, and then I just came up with the 2.1, but I forgot about the last one. So
Oh,
it's
okay, yeah.
3.1.
Right. So there we go, that's correct. 3.1 would be that answer when you add up all of these numbers.
And divided by 1,000.
Right, you add those up, just put plus signs there. And as was stated by many, 3.1 kilometers, because we just put them into kilometers already. All right, so let's try another addition style one. I'm clearing this, hopefully everybody has that. Let's see. I don't think we did this one. Okay, let's try number 1. I cut off a piece, so I'm gonna have to open my book to see it. But you should have your book there so you can make out what's missing. So a printmaker produces her own ink by mixing powdered pigments with water and alcohol. In the morning, she mixed 45 milligrams of red pigment. At noon, she mixed 2 grams of the same red pigment. Later in the afternoon, she mixed an additional 85 centigrams. So she has 45 milligrams, 2 grams, and 85 centigrams. Then it says how many centigrams of red powder pigment did the printmaker use? So clearly you're adding that up, right? 45 milligrams plus 2 grams plus 85 centigrams. And look at what she wants you to end with. So how many centigrams of red powdered pigment did the printmaker use? Now for this one, it might be a little challenging on one part because you're going the opposite direction. And if you scroll up, you can always use the other method to help you. If you've mastered it already, then great for you. But you can also use what we learned before. Remember, as you move over, I had given you guys a longer diagram that shows you how to multiply if you're going in one direction and divide if you're going in the opposite direction. So go ahead and try that one out. All right, Jacob, that's correct. And Adriana? All right, welcome, Johnny. I meant to welcome you when you came in. Good to have you again.
I had surgery.
Oh, I'm glad you're better then. Yeah, I got. Hopefully, you've been seeing the stuff that I've been putting on Remind.
Yeah, I've been seeing it.
Okay, perfect. All right, I see a few answers also come in, Marisol and William, Veronica. Yep, those are all correct. Justine. All right, so let's start going over this one. Once again, remember we talked about this. I had a larger scale here. This can help sometimes when you're working from a bigger value down to a small value. Because the bigger value has been shrunken so that you can represent that large value, you're going to have to multiply big values to represent the smaller units. So if you look here, when you're going from grams, we just have to clear this. All right, when you're going from grams to centigrams, remember a centigram is 100th of a gram. So that means a gram is 100 times a centigram. That's the opposite. Remember I said that's the logic we use for number 9, is just doing the opposite. So that means if I want to change 2 grams into centigrams, I need to multiply that by 100. Now remember, this chart doesn't show all the other ones in the middle, but these are the ones that we use the most: kilometers, meters, centimeters, millimeters. We don't really use the deca and the hecto stuff. So 2 times, this is normally sufficient. Rarely do they ask the other units, but you never know, so just always make sure you review them. But 2 times 100 is going to give 200 centigrams, and that will help us with the first one there. So if we do the first one, remember we had 45 milligrams. What was it? Plus 2 grams plus 85 centigrams. So that means our 45, because it's smaller and we're going larger, we're going to have to divide that, right? So if we divide that by 100, I mean not 100, there's only 1 unit over. If we divide that by 10, right, 45, and you can also try to write it out in terms of a fraction. If you like that fraction method, you could say 45 milli means 1,000th, right? In order to write it in terms of centigrams or hundreds, I would have to move the decimal point over, move the decimal point over. That's one way you could do it as well. Or you could say, in order to get to 1,000, I need to divide it by 10. Hopefully you can see that through all that writing. And what I do to the bottom, I do to the top. So I have to divide that by 10. And if I do, I'll get 4.5 over 100, which is the same as a centigram. Or you can use what I showed you on the above. I'm going from milli to centi, so I'm going to divide by 10 to get there. Right, so those are different methods. And I know some people like one method more than another. Right, so that means my 45 milligrams would be the same as 4.5 centigrams. My 2 grams, as we saw, I have to multiply that because I'm going from a larger value to a smaller value. So that's going to be 200 centigrams, right? And if you were to write that out, just to write on the side, 200 centigrams means 200, right? Because centi means over 100, so 200 200ths, right? So that cancels out, 200 100, sorry. So those will cancel out to 2. So you see, you can even work your way backwards. All right, so 200 centigrams is that middle one. And then the last one is already in centi form. So that's 85 centigrams. All right, and then you just add everything up. You can start with the whole numbers. 200 plus 85 is going to give you 285. And then plus that 4 will give you 289. Oops, I don't know what I was trying to write there. 289.5 centigrams. All right, so that will be answer C. A good bit of you guys got that, and it looks like you guys are getting more and more comfortable with these type of questions. Any questions regarding how to do this? And a few had a slight mix-up. You might have divided, but you should have multiplied, but a good bit of you were able to get C. Any questions? All right, we do like 1 or 2 more, and then we're moving on. We're going to skip, though, to unit 3 just to do 2 lessons and then come right back to unit 2 after that. All right, so I'm gonna clear that. Hopefully no one needed it. If you do, please let me know. And let's see, I think one more should possibly do it.
3.
Yes. Yes. Did I hear my name? I guess not. All right, it was 1. Okay, here we go. Number 15. We're gonna do number 15 there. It's a little bit different than something you might have seen before. Number 15 says, every 10 milliseconds, a mystery substance decreases its weight by half. At time equals to 0, the substance weighs 5 kilograms. Determine its weight at time equals to 3 centiseconds. So this one is good. It definitely challenges your brain here. So try number 15. And if you finish fast, try number 16, which is pretty similar. But you do want to try to see all the different types of problems that can arise. All right, so try number 15. Once again, notice that the first one is in milliseconds. The second one is in centiseconds. The substance is in 5 kilograms, but your answers are all in grams. All right, so keep that in mind as you go. It might help you to write it out too, because we haven't done any algebra. This one could be solved faster if you are good with algebra. If not, it would be good to like try to write out what's happening, like a sequence. All right, if you're having any challenges with this, I'll give you a hint if you need it. Because you're starting, because everything's based off of this every 10 milliseconds, then you want to see what happens. You want to make sure that this, the 3 centi, is in milliseconds, so you can see how far you have gone. So if you're finished, go ahead and try number 16. So I know 2 people have got that correct. Justine and Jacob, well done. Go ahead and try number 16, as that's a little bit different, works the opposite direction. right, it looks like we're gonna have to come in here. Any
Mr.
other
Ray?
answers? Yes,
I sent you my answer. I don't know if I got it right.
for number 16?
Yes.
Okay, number 16 has a little issue there. I just was looking at it. That thing
Yeah,
should,
I'm sorry. I sent my answer too.
yeah, it's, you guys are correct, but the only way you could get that is if this was grams. Because that is what you have a much larger answer if that was kilograms.
Yep, I was when I was multiplying,
Mm-hmm.
I was missing some zeros, so I assumed it was that.
Yeah, it's a little mistake here. I think I have an older edition, so they might have fixed it in a newer edition.
Yeah, mine says kilograms as well.
Okay, yeah. If someone else has grams for number 16, please let me know.
Yeah, but because of the options, I deducted that it had to be that one.
Yeah, that's the only way you're going to get that correct answer, is changing that to grams. So I'm glad you guys were able to get through it. I see that you did. And William, too, you got through to the correct answer. Yeah. All right, well, I'm going to start with the 15. It seems like it might be a little bit challenging. Is it challenging, or have you guys got the answers and just not shared it?
I didn't get it.
Okay. All right, well, thank you for just being honest.
I also didn't get it.
For number 15?
Yeah.
All right.
I just moved down to 16.
Okay. Number 15 is considered a little bit more challenging because it's division versus multiplication.
Yeah, that was kind of a tricky one right there.
Okay. I'm glad it's good. It's a good thing to admit it and to let me know, because that way we can definitely spend a little bit more time on this one. All right, so to start off these, it's always good to have your units in the same, because as I said before, you're starting with the milliseconds. You want to put everything else into milliseconds, right? Because you're doing every 10 milliseconds. If you try to change this to centiseconds, you're not really answering the question. So you want to keep it in every 10 milliseconds, which means this one here is not in milliseconds. So you do want to convert that. And then once you get your final answer, you can either convert it now or convert your answer once you get to the end. Notice that's in kilograms, so you have to convert your answer back into grams. All right, so let's change 3 centiseconds into milliseconds. Does anyone know what 3 centiseconds is as a millisecond? All right, remember, you can always use
3,000.
A little bit too high. Remember, we got, say it again.
1,000?
No, it's not that. Okay, let me write out this real fast. You remember we had this
300.
A little less. Let me use lowercase. So deci, centi, milli. All right, so look at the distance between centi and milli. Would that be hundreds, thousands, or tens?
Thank
Tens. So your centi and milli are right next to each other. So that means they're only one place value apart.
Oh.
Right? Remember, in terms of decimals, the units represent the ones place. Over here, this represents the tenths, the hundredths, and the thousands. On the other side, it represents the tens, the hundreds, and the thousands. It works just like the place value chart. So if you're going from centi to milli, remember at the beginning of this unit, I'm just going to scroll up real fast. You can always use this chart here to help you. That if you're going from larger values to smaller values, you're multiplying. And if you're going from the smaller values to the larger values, you're dividing. So if you're going from centimeters or centigrams or centiliters, centi anything, and you're going to milli, what are you going to do? Multiply by
10.
10, right? Because you're only one apart. Now, this doesn't do it justice, because between kilo and meters, you have hectometers and you have decameters. And between meters and centi, you have decimeters, right? So those are the other ones that are in between. this chart doesn't do it, but I had given you guys, or let you see a chart. I don't know if I ever sent it to you. I could send it to you today. All right, so let me go back to number 15 now. If we go back to 15, that means that our 3 centi, whatever it was, seconds, is really equal to what?
30?
30, right, that's the answer. It's 30, well, not the answer, but that's what is equal to 30 centiseconds. I mean, not centi, 30 milliseconds. Another way to do that is to use the prefixes. If you don't like all those little chart things, use the prefix. What is 3 centiseconds? What does the word centi mean?
Hundreds.
Hundreds. But what do I want mine to be in?
Milli.
Milli. And what's milli?
Thousand.
Thousand. So that means I would have to multiply 100 by 10. And what I do to the bottom?
To the top.
To the top, which means 30 thousandths in terms of the metric system is 30 milliseconds. So if you like doing it that way, it's 30 milliseconds. Does that make sense that this is 30 milliseconds?
Yes.
All right, so now that you know it's 30 milliseconds, well, if you're going every 10 milliseconds and you're starting at time equals 0, you might not know what that means. It just basically means at t equals 0, or your starting amount, you have 5 kilograms of substance. At t equals to 1, right, the next round, that means the next 10 seconds, what has happened to the weight of this substance?
Decreases by half.
Decreases.
By half.
By half. So what's half of 5?
2.5.
2.5.
2.5 kilograms, right? So if I was to write this out, this has been, you know, it's literally the 10 milliseconds, but we just say t equals 1. So if this represents the first 10 seconds right here, then this is the second set of 10 seconds. And we call that t equals to 2. And how much would that be? We're halving every time. So what's half of 2.5?
1.25.
1.25 kilograms. And I'm running out of space, so I'm gonna do a little maneuver in here just so that you can see it better. All right, and then we do another set of 10 seconds, right? And that's my total 30 milliseconds. Does everybody see that? 10 is the t equals 1, t equals 2. Now we're at the 30th one, right? 30 milliseconds. We say t equals 3 because we're just counting the milliseconds. The first set of 10, the second set of 10, now we're at the third set of 10. Does that make sense so far?
Yes.
All right. I heard a All right, so we're halving each time. So what's half of 1.25? You can use your calculator if you need to.
0.625?
0.625 kilograms. So that's our answer, but when we go look at our selection, do we see 0.625 kilograms?
No.
No,
No,
crap.
we only see grams. Now, you could just kind of guess what your answer is going to be in this scenario. Sometimes they make it difficult and they have like 6.25, 625, 62.5, etc. But for here, you could just guess your answer. What do you think it's going to be?
625 grams.
625 grams, right? But that's because you're going to convert the kilograms into grams, right? And remember, kilo means 1,000. There's a few ways you can go about it, but I'm going to stick to one method, the fraction method, and hopefully that really helps. So that means 6.625 kilograms. Kilo means 1,000. So if you times this by 1,000, remember on the whole number side, you multiply. If you times that by 1,000, it's the same as moving the decimal point over 1, 2, 3 times, which will be 625. Or you could just put that in your calculator, 0.625 times 1,000. And so you get the answer of B. Now that's considered like a level 3 or 4 question. Most questions are level 1 and 2, but this is like a level 3 or 4. So don't feel too bad about that. It can pop up on the test. It is a higher level question. If you're able to get it, well done. But it has a lot of steps. So I'll repeat the steps again. And you want to practice that, right? Try to own that question, meaning see if you can explain it to somebody. So go over it until you get it. And as much as you might be frustrated with it, that is the best way to learn something. If you're frustrated with it, if you're like, man, this makes me want to give up, right? That's the question you want to focus on. Because if you can master that question, you master it the next time it comes around. And you never know. I remember one time, a few times actually, even in this class, I've said, you know what, this is one that we need to work on. And then someone's like, actually, that was on the test last time, right? So focus on this one again. I'll repeat it. And I'll just go through it faster. I don't know if did anyone need that. All right, so for this one, every 10 milliseconds, a substance decreases. T equals 0 just means the starting point. So if you don't like putting T equals 0, you could just say starting point was 5 kilograms, right? So then the first 10 milliseconds is going to be half of that 5, which is 2.5 kilograms. The next set of 10 milliseconds would be 20 milliseconds if you don't like T equals 1, 2, etc. And half of 2.5 is going to be 1.25 kilograms. And then the last thing, the 30 milliseconds that we found, right? That's T equals, and you can see now that's T equals 0, T equals 1, T equals 2, T equals to 3, right? That's just the relationship between them. So at the 30 milliseconds, that's where I'm stopping. It's going to be half of 1.25, which is 0.625 kilograms. And because this one only has one relationship like that, it's B. But remember, in order to convert that, kilo is on the unit side. And instead of writing it as a fraction, because it's not in the decimal side, instead of dividing, I'm going to multiply by 1,000, because kilo in the whole number part means 1,000. And milli in the decimal part means 1,000ths, PHS. All right, so 0.625 times 1,000 with the calculator, very easy. Without, because it's 3 zeros, you go to the right, 1, 2, 3. So that's 625 grams. All right? Did that help? The second explanation?
Yes, Mr. Ray. So, and the reason why it's grams is because 1,000 grams in 1 kilogram, right? So
there you go. Right.
Okay.
You could look at it that way as well. If whatever way you get it, and the more you practice, the easier it gets. If you say, I don't want to practice it, the harder it will get. Always face your fears. If you never face your fears, you always be afraid. If you face your fears, you will conquer them, and you can walk around boldly like a lion. All right, let's go ahead and try number 16, and then I'm gonna introduce the next part from unit 3, and it actually kind of builds on this. The scientific notation does, but we may not get to the scientific notation tonight, but we'll at least get to the exponents. All right, so I'm gonna clear this and look at number 16. Number 16 was similar, and you might not have had a chance to get there. It's actually considered easier, but there was a problem here. And if you had tried it, you would have realized that kilograms is not gonna work. The book has a little typo there that should say grams. That's the only way you would get any of the choices that are here. With kilograms, it's gonna be way bigger. All right, so just make sure you change that to grams in your question. So this one's very similar. Every 20 seconds, a mystery substance doubles its weight. I'm talking crazy. A mystery substance doubles its weight. That's a tongue twister, a lot of S's. At time equals 0, the substance weighs 40 milligrams. Determine how long it will take the substance to weigh 0.16 grams. Right, we changed it from kilograms. If we keep it there, we will not find the answer, and it's going to be some really big number. All right, so very similar. if it's written in milligrams, what are we going to have to do with this 0.160 grams? We're going to need to, go ahead.
We need to convert to kilograms.
You need to convert that to kilograms. And what would this be in kilograms?
1,000 milligram in 1 kilo.
Right? It's well, yeah, but we're not using kilograms. And it's not 1,000 actually, it's more like 100,000. So change it from kilograms. If you use kilograms, it's not going to come out right. So change it to grams, and we're changing from grams into milligrams. If you used to write it out this way, if you like using the units chart, the units is in the middle. Remember, units represents the grams, etc., liters. And then on the other side, you have decigram, centigram, milligram. If you used to go from kilo to milli, that's 10 times 10 is 100, 1,000, 10,000, 100,000, 1 million, right? And a million is very large. So if you used to change that kilo to milli, it would be 1 million times that, and that's too large. So it's clearly a typo there. And so instead, we're going from a gram, so that's going to be 10 times 100 times 1,000, right? So if you like it that way, you could do it like that. If you like the fractions, then 1.160 grams times 1,000 is what's going to give you your milligrams. And you can just move the decimal point over 3 times, and that's going to be 160 milligrams. And hopefully you're still with me. I don't know because it's a bit quiet today, but 160 milligrams would be the answer. So remember, you're starting at 40 grams, and you could do the same thing. This time we're doubling instead of dividing. So at time equals 0, you can either write start. I'm going to do all 3 of them there. I'm going to write t equals 0, and then I'm going to put start, just in case the t equals 0 may be a little bit confusing at first. Right, so t equals 0. Let me go up a little bit higher. I don't have a lot of space. Hopefully you do. T equals 0 is the same as the starting time. And the starting time, we're at 40 milligrams. Right, so every 20 seconds, this thing doubles in weight. So the first 20 seconds, right, the first 20 seconds, how much will it weigh?
40.
0?
80?
Well, that's
Oh,
a
in
start.
the original, after the first 80, yeah.
Right, 80 milligrams, right? And that will represent t equals 1. So if they ever ask you like find t equals 2, that's what they mean. The next, then every 20 seconds, so the next 20 seconds will be 40 seconds, which will be t equals to 3, right? They're saying the third time. I mean, not 2, so 3, 2, right? So 40 seconds, it'll be at how much?
At 160.
160, but that's exactly what we wanted, right?
Yeah,
So how many seconds did it take to get there?
40 seconds.
40 seconds. And that would be your answer, C. If you don't change it to kilograms, you'll be there for a very long time. So make sure you change that to grams. Any questions with number 16?
No.
Right? If you ever get questions like that, you can always make charts, right? Make a chart just like you would if you was in a track and field event or a football event, soccer, basketball, and you're trying to see what happens every few seconds. You make a chart, right? Treat math like it's just something you would do in real life. And so, you know, sometimes act like it's money. If every 20 seconds your bank account doubled, I'm pretty sure you can track where it will go. So think money, that can normally help you out. All right, we're going to stop there. If there are no other questions regarding the metric measurement system. Going once, Going twice.
Now we just gotta keep practicing, Mr. Ray.
I'm not too confident with this.
You say you do or you don't?
I'm not confident with this.
Okay, we could do a few more. Because I'll be honest, if I introduce the next thing, you might feel more overwhelmed. Because we are leaving unit 1. Yeah, we're done with unit 1. We're entering into the algebra round and application round. So if you want me to do a few more, let me know.
To my opinion is that when we let us move forward, then we at times we do revisions. That's how I think.
Yeah, that's good at times, but sometimes it can be overwhelming. I'll just be honest.
Because when we do that revision, we refresh our brain and call for the past event that we just go through.
Well, there's two arguments. One argument is to try to finish as much as you can, and then the other argument is to be efficient on what you know. Sometimes being proficient on what you know is better than just covering a lot of information. So being able to get 100% on 6 questions is better than to be able to finish 10 questions but only get 20% on it, if you get what I'm saying. All right, so we'll do like one more. Okay. Remember, I sent you guys worksheets on the basics of this, so you want to definitely practice those. And not only do you want to practice them, you want to practice what we don't cover. And I'm begging you now, please have questions on Tuesday regarding questions from this chapter. So go ahead and do the ones I haven't done and bring the questions to class on Tuesday. All right, so, and remember, if you can't do it here, you won't be able to do it in geometry and algebra. So we really have to master this down. So let's practice it one more time. I'm just going to choose number 12. Yeah, let's do number 12. A building shown in a magazine is 50. This is easier than the other two. The other two were, you could consider those the peak questions, right? Those are the harder questions that you would get. So if you're able to do those two, this one shouldn't be too difficult. So a building shown in a magazine is 50 millimeters tall. Darlene is making a scale drawing of the building. She wants her drawing to be 4 times the size shown in the magazine. How tall will her drawing of the building be?
This is millimeters.
So I'm not going to say your name because I don't want to call out, but the person who sent me the message about the email, I'm inviting you to Remind. So you should see a message. If you don't have Remind, it's one of the easiest ways to communicate, especially because I have multiple classes. So trying to remember to email individuals who are not on Remind makes it very hard, and more than likely I'll leave you out. So I'm sending you an invite to join Remind, and I'm going to send it via the email you sent me. Just to ask you, it's 3 AMs there in your email? If you could just say yes. I see 3 AMs. I'm not sure if that was a typo. Okay, so it is 3 AMs. All right. Three. All right.
Mr. Ray,
Yes.
I think I got this one for a change.
Well, that's good. That's really good.
You want me to send you the answer?
Yes, please send me the answer once you get it. And okay, yeah, that's correct, Gennaro. Like I said, this one would be easier, build the confidence a bit. The other two were a bit more difficult, so.
Okay.
I'm just trying to get back to my screen. I was trying to add somebody to remind. I have so much stuff open. Okay, here we go. All right, well, again, multiple answers coming in. Now, there we go. Let's build up the confidence a bit. Pick a few easy ones before we move on. All right, so those who have sent those answers in, they are correct. And if you haven't sent it in, I'm just going to start it because I do want to at least start the other section today, and at least get your brains rolling there. All right, so just remember, she sees something in a magazine, it's coming up as 50 millimeters. She wants to make it 4 times the size, right? That's literally just straightforward. Let me just write back to you real quick. So sorry about that, just trying to write somebody back. She wants, where was I? She wants it to be 4 times that amount, right? So what do you do there? Just times it by 4. And 4 times 50 is?
100.
200, right? Now you can guess the answer once you see that, right? And I'm pretty sure most of you did, but I'm gonna guess carefully because there's a 2 meters there and a 20 centimeters. So your guess has to come under the concept of what is a millimeter, right? Is 2 meters the same as 200 millimeters?
No.
The key word there is 100. No, right? 200 centimeters is the same as 2 meters, not 200 millimeters, right? If you use the concept of the milli. So 200 milli, what does milli mean again?
1,000.
1,000, right?
1,000.
So if you wrote it as 1,000, and remember, it's 1 unit away, so you took 1 unit down, you changed it now to centimeters. And so that's 20 centimeters. Or if you had it in that unit thing, we have units here, deci, centi, milli. Remember, if you go in this direction, you are dividing by 10. So you could just say 200 divided by 10 will get you to the centimeters. Or you can even write it out as a decimal. 200 millimeters is going to be written as right, so 200 millimeters is like that. And so if you drop off a 0, you're now at 20 centimeters. Right, so, that's different ways that you could go about doing that. I'm trying to stick with the fraction, so I'll do the fraction one more time. If you get your 200 millimeters, milli means 1,000, so 200 over 1,000. Centi is 1 unit over, so like literally go 1 unit over, and that's 20 centimeters. All right, so that's how you do that one. And I see something in the chat. All right, hopefully I didn't erase that too fast. Who was trying to take a picture. All right, I think that should help you out a bit for homework. Try to finish everything else I did not do. Please try it, and please have questions if you run into any trouble, right? I did not do number 8, so try number 8 for homework. I didn't do number 10, 11, so number 8 through 11. I think that we do 9. So yeah, 8, 10, 11, 13, 14. And then this whole page we didn't do. So if you do those questions there, the whole page here. You want to do that, and numbers 8, 10, and 14. Please try it. If you can master the metric system, it really makes life easier. So 8, 10, 14, and I'm just going to point down, arrow, this whole page. That's what you want to be working on. Try to do the worksheets first that I've already sent. If you do those worksheets first, it's going to build you up to this because it just practices converting between like liters and kiloliters, centiliters and milliliters, etc. Right? Just practice that. Most of you showed that you had no problems with the imperial measurement, so I don't think we need to worry about those, but you can still practice them. All right, so we are moving on. Moving on. Remember, that's from the workbook.
What questions was there, Mr. Ray? 8, 10, and what else?
8, 10, 14, and then all of page 33.
In the workbook?
In the workbook.
Sorry, you said 8, 10, 11, 13, 14, and then 17 and beyond.
Right, there we go.
8, 10, and 14.
8, 10, 11,
oh, 11.
and 14.
Okay.
And 13.
I said 13 too? Thank you.
Yeah.
Great. Thank you for being my brain there. So 8, 10, 11, 13, and 14. So skip number 12. So basically 8 through 14, we did 12 in class just now. So 8 through 14, and then 17 onwards. All right, so make sure you do those things there, and let's now move on. We just looked at the metric system. Pretty soon we're going to be doing something that's very similar called scientific notation. We're going to skip over to Unit 3. You could close your workbook for now. I don't think we're going to go back to it today. But what we're going to look at now is squares, cubes, and cube roots, because we are going to be working on scientific notation. And scientific notation, if you look very closely there, scientific notation looks very similar to what we've been doing all this time with the metric system and stuff. But it has these little numbers there. And so we need to learn about these numbers first. And those numbers, we call them exponents. And we're going to start off with the lowest exponents that are the most popular. And that's squares, cubes, and cube roots.
Sorry, what page are you on?
This is in the, let me see if the page is on here.
54.
54, thank you.
That student book?
Yes, the student book. 54 in the student book. All right, we're going to go to do a real easy task first. And so although I'm on page 54, we are going to just practice writing this out. Now, trust me, you want to write it out. It makes life easier. But before we do that, let me just say what a square is. A square is a number that when you multiply by itself, you get an answer. And that square is the result. So for instance here, 5 times 5 is 25. We call that 25 a square. Now the reason why we call it a square goes back to the concept of the area that most of you should have a general understanding. Most times when you were taught, hopefully, how to multiply numbers, you learned it by doing like those little blocks and stuff, right? And so when you multiply blocks that have the same length on either side, well, that becomes 3 times 3, and we call that the area of a square, which is 9 in this scenario. And so the area of a square, which is simply multiplying 2 numbers by themselves, we nickname it, and we just call it a square. And so a square is simply multiplying a number by itself. Right? And that's the result. So 1 times 1 is 1. 2 times 2 is 4. Right? So what I want you to do is simply to write out the square numbers up until 12. You want to have them written down. Trust me, I said that with my other class, and then a few people didn't write it down, and then when we did the next activity and I was telling them to look at what they wrote down, they're like, oh, I didn't write it down. So please make sure you write it down, right? 1 times 1 is 1, and I want you to do it right up until 12 times 12. You want to have those in your mind. So if you already know your multiplication tables, this should be a breeze. But you still want to have it written down so you get used to seeing it. right? So that's what you're doing now. Should be a real easy task. 1 times 1 is 1. 2 times 2 is 4. What's 3 times 3?
9.
9.
4 times 4.
16.
5 times 5.
20.
25.
25. 6 times 6.
25.
36.
36.
36.
All right. 7 times 7. Might not be able to see that.
49.
9. 8 times 8.
64.
64.
9 times 9.
81.
81.
10 times 10.
100.
100.
11 times 11.
111.
Close. You add the 2 in the middle.
121.
No, 121.
And then the last thing that we're going to work up to, 12 times 12.
144.
144. All right.
144.
You can learn up to 15. It's good to know 15. But 12, most people expect that you know the perfect squares. We also call them perfect squares. So these are the squares. The 1, the 4, the 9, 16, 25, 36, 49, etc. Those are what we call the squares. All right, so you want to make sure you have those down. Title the squares. Now, the opposite of squares, we call them the square roots. And that is just doing the opposite. You go from the square back to the number that you multiply, but you only state the one number. So for instance, we know that, and the way that we write the squares, forgive me, normally I have you guys do that, it's probably because it's late. But 1 times 1, the way that we write that is we say 1 squared. So maybe you could put it on the left side. Forgive me for not having it in the middle. 2 times 2, we say that's 2 squared, right? When we put that number up there, we call it a square. And in reality, it's called an exponent as well. And so that is what the 4 is. And 3 times 3, obviously, that's 3 cubed, which is, not tired, 3 squared, which is 9, etc. So you could put those in, those little exponents, that's what we call them. You just put a little 2 on the top. It's what we call superscript, meaning that super means above and script means like font or to write. So we're writing on above. So not right next to it, don't write that, that's 12. You are writing 1 to the power of 2. That's another way to say it, 1 squared, right? 2 squared, 3 squared. So that's the same thing as saying a number times itself. So the square root is the opposite of that. So if 3 squared is equal to 9, and I want to see, let's say I didn't know what it was that gave me 9, the opposite of that is to do what's called the square root. So this little symbol that I drew is called the square root. So the square root of 9 is equal to 3.
3.
You're going to learn a little bit later, it's a little bit more than that. But for now, square root of 9 is equal to 3. The square root of 25, what do you think that would be equal to?
5.
5.
5. How about the square root of 121?
12.
11.
Close, 11, yes.
I got it.
How about the square root of 81?
9.
9.
9.
How about the square root of 49?
7.
7, right? And so that's what we call the square roots, right? The square root is the opposite of squaring. It takes, and when you take the square root of a perfect square, you get what's called the final answer. What I'm looking for, if I sound like I'm distracted, I'm bringing up the calculator just to show you how to do it on your calculator now. And we're using all this because we're going to use our understanding of the place value chart to use scientific notation. And I want to make sure I get this before we run out of time. So you could take out your calculators just to practice doing that. And I'm about to share my screen in a moment, just trying to get it up and running. All right, so I'm gonna reshare. And calculator. All right, so if you use your calculator, and make sure you are practicing using that calculator. Like I told you, if you don't practice it, you're gonna get on the test and try it and then waste time, because a lot of times people get on there, they're like, oh man, this is not working like I thought. And then time is going while they're trying to figure out how to use the calculator. So make sure you practice using your calculator on a regular. All right, so to do the squares, you have two options. There's a button specifically to do squares, and then there's the option just to raise it to a power. So it's this button and this button right here, these two buttons. So if you want to just work with squares, you could just hit that square button with the X squared. So the way you do it is just put 2 and hit the button, and you see on the display, it says 2 squared. You hit enter, and it gives you your 4. 3 squared gives you the 9. 4 squared gives you the 16. So that means if you want to know like bigger numbers such as 13, you could do that really fast. Or if you want
Mr. Ray, start it again. Let me see. Let me try it with my calculator. Where should I start? I start with the square or the sum button?
The square button is the easier one to start with because it's just specifically and only works for squares.
Okay.
So you just put a number and then you hit the square button and then hit enter. Right, and all the squares that you have, you can check them out and it's just going to work it out for you. All right, so that's how you do the square. If you want to just do it generically, that means for any exponent, which we'll learn about soon. Let's say you want to do 8 squared, but not use the square button. You hit the button 8, and then you're going to hit this little button that my professors called caret. Right, when you push that button, it gives you the choice to put any number in there. And we're going to learn about that. You can put any number in there, but for now, we're working with the square or the 2. And so you just put 2 in there, and you can get 64, just the same. But when you're working with squares, it's easier just to work with the square button instead and use the other one for the other powers when we get to them. All right, the last thing that I definitely want to touch today is the square root. If we have time, you do the cube. But the square root, remember, we were just writing that. The square root of 81, we said was 9, and the square root of 64 is 8, etc. Square root 121 is 11. Similarly, your calculator is literally a computer. Your calculator can do that as well. If you look at your square button, what do you see above it in green? Well, you see the square root, right?
Yes.
That's called the square root. So make sure you write that in there. That's the square root button. So you obviously, how do you get to that green? Who remembers?
The second button. The
Second.
green second button.
Right, and then the button. Right, and once you do that, you see the option to write inside of there. So if I do the first one, 81, you could hit enter or you could bring the arrow out. Either way, you still get the same answer. Square root of 81 is 9. The square root, sorry, I put that second square root of 64 is 8. Right, hit the second button to get to the square root sign. 121 is 11. Right, and so that's how you do those buttons. Did I hear a question?
Yes, what button are you clicking for that one, for the square roots?
It's the same button, right? The square root is the opposite of squaring, so it's on the same button. You just have to hit the second button to get there.
So I'll click the second and then the number, or?
No, you hit second and then the square button.
Okay.
Right, because right above the square button is the square root. I don't know if everybody can see that, but the square root.
Yes, I can see it.
Yeah, they have the inverse or the opposite of the square on the same button. So you have to hit second and then the square.
Got it, thank you.
All right, perfect. All right, the other thing, we have 6 minutes. Let me see if I can squeeze this one in. It's not that difficult, is what we call the cube. Does anyone know what cube is? What number represents a cube?
3.
3, right? If you know a cube is a dice, right? Or a Rubik's cube, right? Rubik's cube has length, volume, is 3-dimensional basically. Whereas a square is 2-dimensional. That's why it's a square. So a cube has 3 sides and all 3 sides are equal. So if I was to draw a little cube up here, right? And then they were all equal, and I had 3 times 3 times 3, the volume of that would be 3 times 3 times 3, which is the same as 3 cubed. And 3 cubed
That would be
is
27.
27. Right? And if I was to change those values, if I was to have 2 there, 2 times 2 times 2, which gives me volume of any shape, is 2 to the power of 3, which, yes, is 8. So it's also good to know your cubes, at least up to like number 6. You don't really have to know them because your calculator could do them. Most people expect you to know the squares and square roots. The cubes and cube roots, some people do, some people don't. All right, so you can write them out if you want. If you want to write out what the cubes are, you could do 1 through 12 as well, but just for time's sake, I just want to show you how to do it on your calculator. And before I do that, let me just go over what the opposite is. The opposite of a cube is a cube root. Now the way that we write the cube roots, let me just do like one more. The way that we write the cube roots, well, let me do the cube, sorry, on the calculator. To do the cube on the calculator, we just say 3, and then we use the caret button. So you should see it highlighted in red, that little triangular looking shape. And then you type in the number 3. And then you hit enter and you get 27. Right? To do 2 cubed, 2, hit that button, the 3, and then hit enter, 8. Right? 4 cubed, 64. Right? So if you want to find out like other numbers, like bigger numbers, such as 8 cubed, 512. Right? If you want to see what 11 cubed was, I think it's 1331. Yep. And 12 cubed, if you wanted to see that, 1728. All right, so that's how you do the cubes in the calculator. And then the last thing that we're going to do for tonight is the opposite. What if I wanted to find out how to get back to that, right? To do that, just the same way, the inverse of that is on the same button. So that button there, if you look closely, right above it, you see that X and then the root sign. Well, the way that works is, first let me write it out for you. It's called the cube root. So whatever is in that little nook there, we say that and then the root. So since the 3 is there, we say cube root. If it was a 4 there, we would say the 4th root. If it was a 5, 5th root, 6th root, etc. So that's the cube root. And the way that we do it in the calculator, just to clear everything there, of course, you're going to have to put the 3 first, just like how you see it, right? The 3 comes before the root sign. So you hit the number 3, you hit second, and the moment you hit that button, you look what happens to the 3. It shrinks to represent cube root. And now you can put the number in there. So if I did the cube root of 27, does anyone have any idea what the cube root of 27 would be based off of what we just done?
3.
3.
It would be 3, right? Because 3 times 3 times 3 is 27. So if I do the cube root of 3, sorry, not 3. If I do the cube root of 27, we get, forgot it's going to do that. Be careful, because if you don't hit that button, you see that it's multiplying. So I'm glad that came up. 3 second, make sure that thing shrinks before you push enter. 27, and so then you get the 3. Right? If I do the cube root of, right, make sure it shrinks. Cube root of, right? Once it shrinks, you know you got it. 8 is going to be 2. And so all those different ones we practice, we can get it. So we're going to pick up there. But remember, for Tuesday, you want to at least have tried to do some those problems. The more you do, the better. I know it's the weekend, so if you carve out your time, try to do 2 questions a night. Shouldn't be too much. You're prepping for a test, so you know your weekends can change just a bit. And then Tuesday, have it ready. Any questions that you might have. We'll pick up with this and scientific notation. So that's going to be those 2 lessons of back-to-back in Unit 3, and then we come back to Unit 2 and we're going to do length, volume, and perimeter area volume, sorry. And so we're going to start to pick it up just a tad. And so make sure you study and practice. And if you have questions, please feel free to ask them. Do not be timid to ask. All right, you guys enjoy your weekends. If there are no other questions, you're officially dismissed.
Thank you.
You're welcome.
Thank you. Thank you, sir.
You're welcome. Enjoy your
I still have
evening.
a question.
Yeah, if you have a question, just stay back for a moment while I can answer them.
I'll have a bunch on Tuesday.
Yeah, that's what I want.
I'll give you a bunch of questions.
I'm looking forward to the questions.
Okay. Thank you, sir. Good night.
You're welcome. Have a great evening.
Thank you.
Yeah, the question is, how do you make the cubic root to be outside the square?
Okay,
I
let me
need to
show
stick
that
again
again.
on the calculator.
Let me just clear that. So you hit the 3 first.
Okay, 3 first.
Then you hit the second button.
Okay, the second button.
And then you go to where that caret is that's highlighted. And once you do that, it's going to shrink to 3.
Okay. Okay, got it.
Right. And now if you
Thank
put
you
any
so much.
number in, you get your answer.
Okay. Thank you.
All right. You're welcome. I'm going to send another worksheet just so you guys could, I know it's a lot of work, but you know, that's the point. All right. Have a great evening.
You too.
Thank you. All right. See you guys.
Mr. Ray.
You're welcome, Justine and Dina.
All right, bye, Mr. Ray.
See you later. Good to have you here.
Thank you.
You're welcome.
Bye.
Bye-bye. All right.
Okay.
All right, George. Have a great evening.
Okay. Bye, Mr. Ray.
All right. Keep
See you
practicing.
Tuesday.
Keep it up. See you Tuesday.
Bye.
All right. Bye-bye.